Have you ever done this? The patterns you see when you push on the screen of a calculator are caused by the liquid crystals that are used to create these liquid crystal displays, or LCDs. Liquid crystal displays are found on many devices with screens. You may even be watching this video on a liquid crystal display right now. Liquid crystals have properties that make them perfect for these types of displays. To better understand the properties of liquid crystals, we'll start by looking at the two most familiar phases of matter, solids and liquids. In a crystalline solid, like ice, molecules are locked in a rigid structure. On the other hand, the molecules in liquids, like water, move and vibrate, allowing the liquid to flow and take the shape of its container. Between these states of matter, we find liquid crystals, materials that behave like both a crystalline solid and a liquid. To the naked eye, liquid crystals look like a wax or paste, not exactly solid and not exactly liquid. But it's when we go to the nanoscale to see things at the molecular level that things get more interesting. The molecules within liquid crystals are able to flow and move around, like in a liquid, but their orientation is more rigid, like in crystalline solids. That means that when the molecules within a liquid crystal move, they move and rotate together in groups with their neighbors. In an LCD, a layer of liquid crystal is sandwiched between two polarizing filters. When polarizing filters are crossed, all light is blocked and the filters appear dark. Liquid crystal between the polarizers will affect how light passes through the filters. When a voltage is applied to the liquid crystal by a battery or outlet, the molecules in the liquid crystal change orientation, allowing a certain amount of light to pass through the second polarizing filter. A voltage applied across a liquid crystal is not the only thing that can cause molecules within a liquid crystal to change orientation. Researchers at the University of Wisconsin-Madison MRSEC have created a way to get liquid crystals to change orientation in response to chemicals or solvents that cause a permanent marker to have it smell. Here's how it works. In this chamber slide, there's a small piece of plastic coated with a liquid crystal. The liquid crystal is currently well ordered and appears bright. When the permanent marker is put into the chamber, solvents diffuse over the plastic and push around the molecules forming the liquid crystal, causing them to become disordered. As the molecules within the liquid crystal become disordered, they change orientation, which gives rise to the change in color that we see. Scientists at the University of Wisconsin-Madison MRSEC are using this ability of chemicals to change the orientations of molecules within liquid crystals to engineer sensors. These sensors can detect chemicals that are much more dangerous than the solvents that give permanent markers their smell.
So this is a sensor based on liquid crystal technology. It's meant to detect a chemical called hydrogen sulfide. And hydrogen sulfide is a very poisonous chemical that is often found in gas and oil drilling operations. The way it works is that we have a film of liquid crystal that is sandwiched between two glass plates. Okay? And one of the glass plates is treated with a special chemical that reacts to the presence of hydrogen sulfide. Now, when this hydrogen sulfide comes in, it displaces the molecules of the liquid crystals, and the liquid crystal changes orientation. When the orientation of the molecules of the liquid crystal changes, it induces an optical effect on the sample.
And the researchers at UW-MRSEC aren't stopping there. By putting liquid crystals into tiny microscopic droplets, scientists are even able to use them to detect chemicals in individual cells.
So historically, interest in liquid crystalline materials has revolved around their use in displays of the type that you might find in your smartphone. Our goals are very different. What we want to do is we want to use them as the basis of amplifiers, materials that can amplify nanoscopic events that you can't see into the visual scale and use them as the basis of sensors. So when used in this context, liquid crystals offer exciting opportunities to create a range of different types of sensors. In the future, we hope to be able to detect a wide range of biological targets.
And this is just one of the many amazing materials that scientists and engineers at the University of Wisconsin-Madison MRSEC are studying in order to make the world a better, safer, and healthier place. To learn more about liquid crystals and how to make your own, visit our website.